Section 5 has some multiple angle identities. It's really just a continuation of the identities you've already seen. Instead of doing something like A plus B, it's situations where it's exactly twice the angle, so it's like A plus another A, and you're trying to figure out what the trig values would be of those new angles. To do this, I'm just going to derive it from the sum of two angle identities that we just did in the last section. So for sine of 2u, I'm going to think of that as being sine u plus another u. And if that's the case, then we can write as sine u cosine u plus another sine u cosine u. So 2 sine u times cosine u. For cosine 2u, same approach, cosine of u plus u. So that would be cosine u times another cosine u minus, because this is a plus, it's the opposite sign, sine u times sine u. So that could be cosine squared u minus sine squared u. Now here's another situation where that Pythagorean identity is going to pop back up. So this is one way to do it. There's actually two more, and as you go through the homework, you'll see it's just kind of whichever one is the most convenient to use. They're all the same. Some situations this is good, some situations you want to use one of the other two ways to write it. So one more time with this Pythagorean identity, 1 equals sine squared x plus cosine squared x. And two ways we can rearrange that. We can write it as 1 minus sine squared x is cosine squared x. Or we can solve it for cosine. Cosine squared x is equal to 1 minus sine squared x. And I'll use both of those. So another way to rewrite this identity, let's try substituting cosine squared with 1 minus sine squared. So if I do it that way, it's 1 minus 2 sine squared x. And if I go the route where I use this one, where I take cosine squared x and substitute 1 minus cosine squared x in place of sine squared x. So now I'm going to distribute the negatives, so that's going to be cosine minus another negative, so really plus another cosine. 2 cosine squared x, and then minus 1. So there are the three ways you can do that identity. All right, now let's take a look at tangent. So if this was tangent u plus u, then it would be tangent u plus another tangent u. On the bottom, you'd have 1 minus tangent u times tangent u. So this would be 2 tangent u's on top, and then 1 minus tangent squared u on the bottom. Now overall, I don't really recommend that you flat out memorize these unless you're just really good at it. They're pretty easy to derive. It didn't take long to derive any of those. But it's up to you. If you can derive them really quick, that's good enough. If you are more comfortable memorizing them, that's fine too. You'll probably pretty much have these memorized after doing them a few times. They're not too bad to remember. All right, so let's apply the identities, and we'll end up having to do a little bit of factoring because we're going to be solving some equations here. So right off on this one, I've got sine 2x, so it seems like a good time to try out my new identity. So that's 2 sine x times cosine x. All right, this part right now, I don't see anything I can really do to change that. So always be looking for what you can factor. They have a 2 in common, they also have a cosine x in common. So let's take that out. That leaves me with sine x here plus just 1 over there. And now that you have two factors set equal to 0, set each one separately equal to 0, and then let's solve and see what we get. So for this one, cosine of x would be 0 if I divide by 2 on both sides. For this one, sine of x would equal negative 1. All right, so let's think about a unit circle. Where is cosine 0? Okay, well that happens when the x value is 0, so here and here. It's pi over 2 and 3 pi over 2. And they're exactly a half a circle apart. So the way I would answer that would be pi over 2 plus pi in radians. Now where is sine going to be negative 1? Well, that happens when the y value is negative 1, so down here at 3 pi over 2. But we've already got that. So I could say it this way. I could say, all right, when 3 pi over 2 plus every 2 pi in radians, but that's already included in this. So it's really unnecessary. It's a true statement, but I really wouldn't do anything. I wouldn't circle it and include it as my final answer. I would say this right here is my final answer. All right, so suppose the cosine of x is 12 over 13, and I'm supposed to find all these different things. So what I would recommend on here first, don't get too carried away with all that yet. Let's just see if we can figure out what this would look like. And I'm going to go back to a triangle. This is kind of what we were doing early in the chapter 4. But if cosine of x is this ratio, then if I put x right here, and you can put it either here or there, it really doesn't matter. Just make sure you put the correct sides in relation to it. So if it's a cosine, hypotenuse is 13, and the adjacent angle to x is 12, or adjacent side to x is 12. Now, the side opposite of that, this is Pythagorean triple, but you can do Pythagorean theorem to figure it out. It's got to be 5 over here. Well, it would have been nice to draw it to scale, but it really doesn't matter. So if I need to, I can write out some trig ratios, but we should be okay here. I should be able to get these pretty quick visually at this point. Sine of x would be 5 over 13. Tangent would be 5 over 12. If you need to find all 6 trig functions at this stage, you should be able to do it pretty quick. But we're going to need to find several of those trig functions to finish this up. So sine of 2x, well, we know that's the same thing as 2 sine x times cosine x. All right, well, we do know already that cosine x is 12 over 13. Of course, we could use the triangle to get that. Sine x would be 5 over 13, so let's go ahead and put that in here. And if you finish that up, you're going to get 2 times 5, which is 10, times 12, so 120 on top, and 169 on the bottom. And that would be your answer for that part. For cosine of 2x, it really doesn't, you can pick whichever one of these 3 versions you like for this one. I'm going to stick with the cosine squared x minus sine squared x. All right, well, I know that, first of all, I know that cosine squared x is the same thing as cosine x squared. So I'll take that value and square it. So 12/13 squared minus sine, which we said was 5/13. We square that. So that's going to be 144 minus 25. And I put them together because they're both over 13 squared, which is 169. So to wrap that up, we're going to get 119 over 169. So tangent of 2x is going to be 2 tangent x over 1 minus tangent squared x. If we reference a triangle again, tangent would be opposite over adjacent, so 5/12. So remember that as we go through here. So 2 times tangent of x, which is 5/12, over 1 minus 5/12 squared. So that's going to be 10/12 over 1 minus 25, 1/44. So 10/12 on top. On the bottom here, we're going to have, if you make this 144 over 144 for the 1, 144 over 25 we know is 119 over 144, because we did 144 minus 25 earlier. It's actually right there. So let's flip and multiply. So 10/12 times 144 over 119. Reduce what we can, that's going to be 12. So finish it up, 120 over 119.